So let's start with our fourth video, in which we will start talking about slide 20. Again, just to remind ourselves, concentration at certain time equal the constant, which is K. K. This is the whole constant that we have multiplied to. Okay. Now, this is my profile, right? By exponential term, okay? Because we have by exponential term in the equation, okay? Assuming the normal condition in which the elimination is the rate limiting step, which means the absorption is faster. If we wait longer period of time, okay, enough time for the drug, then I will reach the point in which the absorption is completed to an extent this turns to be what? 0. So your equation will be similar to this, okay, if we waited enough time for my absorption to end, okay? If you think about it, this we call it my terminal phase, right? For that reason, because the equation can be collapsed to the whole constant multiplied to minus k time, multiplied to the time, right? So this, whatever the constant is, similar to something that you already know, right? And this can be also in the term of ln concentration at certain time, which is ln A, the constant, minus k with time, or log concentration at certain time, which is log constant minus k over 2.303 multiplied with time. Different kind of equations under the condition that enough time is passed. So I'm in my terminal phase, so the absorption is completed, so this term turned to be 0. Okay? If we have the profile of those, which is this on rectilinear, you can have this on semilog as concentration versus time, and it will be curved, and this, okay? If we are talking about ln CB versus time, it will be curved, and then this is rectilinear, and then if you have log CB versus time, this will be curved, and this rectilinear too. Okay, this is the profile whatsoever the equation. So let's go back. This the profile that we are talking about. You can have it on rectilinear. It's not here to rectilinear, but as concentration. If you return it to semilog, rectilinear transformed to ln or log, this is the profile that you have. But according to this, if I wait enough time in any of those profile, which is the same as this profile, I can use this terminal phase to determine one thing, اعتمادا according to this equation, which is I'm using the terminal phase to determine certain kind of thing according to those equations. I can do a linear regression. Again, I'm using here the semilog, which is not a good example because you can't do linear regression unless you transform your data. So I will just linear regression here, okay, or here, to have an equation of or minus, let's say, Tx plus d. Okay, so you can have this is the linear regression of your terminal phase, okay, which means that I'm waiting enough time for my drug to be completely absorbed. So I can, according to this, which is absorption is 0, to do linear regression only to the terminal phase. I can take 3 or more points in the terminal phase to do so. Okay? If I do this, I can use the slope to determine, according to those equations, minus k and ln, okay, and log minus k over 2.303. So the slope that we have in here or in here, right? For the intercept, if we do extrapolation of the linear regression of the terminal phase, again extrapolation of the linear regression of the terminal phase, I will have the intercept, right? The intercept according to the equations will be equal to, let's go to ln CP, ln A, which is ln the whole term. And in here, it will be equal to what? Ln log, A, right? So again, we can determine the slope in each one of them. We can determine the intercept. So you can determine k, which is what we need to do, and you can determine the whole constant that you have here. If we go back to the semilog, whatever you know is still valid under one condition. This will be A as it is, which is the whole constant, right? And in here, you need to change your profile because you have it as this, right? You either have it as log or ln to work on it, or if you have 2 points, as we already know, but you need to do or exponential equation, which we didn't train ourselves to do so, right? So we will go back to whatever you know here and the ln or log, okay? And this is what you already have in your slide 23, okay? If you determine the k from those, according to this, from your terminal phase, you can determine the elimination half-life by doing 0.693 over k, okay? And when we are talking about elimination half-life, you can call it elimination half-life or biological half-life or just half-life, okay? And all of this will be the elimination half-life of the drug, okay? And I will stop here to continue with the residual method, which will take some time. In this slide or in this explanation, I show you how we can determine K and its related half-life.